In this video, I'm going to continue solving the sample AP Precalculus questions given by the College Board in the course description. Okay, so we left off on number 10. Let's continue. Table gives values of the function g for selected values of x. Function f is given by f of x is 3 to x plus x squared. What is the value of f of g of 3? This is testing if you know what a composite function is. So what is g of 3? G of 3 in the table is negative 2. So we just want f of negative 2. As simple as that. So what is f of negative 2? That would be 3 to the negative 2 power plus negative 2 squared. So what's 3 to negative 2 in the power? That's 1 over 3 squared, which is 1 over 9, plus 4. Okay? Clearly, this is the only one with a fraction, because we would be left with a fraction, right? So the answer is B. As simple as that. You don't even need to simplify it. It's a multiple choice. Okay. Food vendor developed a new sandwich type for sale. Vendor made estimates about the sales of the new sandwich type over time. Linear regression was used to develop a model for the sales over time. The figure shows a graph of the residuals of the linear regression, which the following statements about the linear regression is true. So when we talk about residuals and all that, you can think of it as error. I think residual and error, the sign just flips, so it would be flipped. But conceptually, they're very similar. Okay, so when there's a pattern in the error, then it's not a good model. So hopefully that sounds familiar when we talk about modeling and all that, right? Ideally, there should be like no pattern. It should just be random residuals, a random error. That means it's a pretty good model, right? So let's look at the choices. Linear model is not appropriate. Linear model is not appropriate. Is appropriate. Is appropriate. We just said there is a pattern. All right, hopefully I said that already. There's obviously a parabolic pattern here, so it's probably not a good model, okay? So we can eliminate C and D. All right, now what does it say? There's a clear pattern in the graph of the residuals, so it's probably answer A. What does B say though? The graph of the residuals has more points above 0 than below 0. That doesn't matter at all right? If it's always above 0, but it's like random-like, it's totally fine. If it's always below 0 and it's random-like, that's totally fine also. It doesn't matter how many points are above, how many points are below. It totally doesn't matter. So it's A. All right. The value in millions of dollars of transactions processed by an online payment platform is modeled by function M. Value is expected to increase by 6.1% each quarter of a year. At time t is 0, $54 million of transactions were processed. If t is measured in years, which of the following is an expression for M? Note a quarter is 1/4 of a year. Okay, so let's write the model as a function of each quarter year first. Okay, that's what I would do. Okay, you could just jump to this already, but I'll go step by step. Okay, since they tell us that it's increasing by 6.1% each quarter of a year, it should hopefully signal or remind you that this is exponential growth. All right. So to model it, if we want like M of Q, where Q is each quarter of a year, we have our initial value, 54 million. Okay. And then what would the rate be? It's increasing by 6.1% each quarter. So it'll be 1.061 to the Q. Okay, so this is the model for quarters of years, okay? But we are interested in years. So we want M of T, okay? So we basically want to change, they even tell us this hint, a quarter is 1/4 of a year. So in 4 quarters, it's equal to 1 year, okay? So we can let T equal to, actually, is it T? So this is the confusing part. Is it T is equal to 4Q or Q is equal to 4T? That's the confusing part you cannot get mixed up with. I believe it should be like this then. T is equal to 4Q. Actually, okay, so we know that quarter is 1/4 of a year. Okay, so when we get, so we want when q is equal to 4, so 4/4 is same thing as m when t is equal to 1. So 1 year, 4/4. We want our models to be equivalent. So maybe let me even do like whatever that symbol is. All right, whoops. This is getting messy now. Sorry about that. Okay. Capital M and M tilde, is that the symbol name? I don't remember. All right. So we want these to be equivalent. Hopefully that makes sense. So we already have a model for quarters. Now we want it for years. So how do we convert it appropriately? So as I just said, when Q is 4, that's the same thing as T is 1, right? So it should be 54, 1.061 to the 4 for Q, which is T, right? So 4T. All right. So once again, let's check that this is correct. Okay. When Q is 4, it'll be 54, 1.061 to the 4th power, right? That's 4/4. It should equal to when T is 1. So 54 times 1.061 to the 4 times 1, which is 4, was the same, right? So the answer is D. Okay. I believe this is a similar question. Iodine 131 has a half-life of 8 days. In a particular sample, the amount of iodine remaining after D days can be multiplied by the sky, where A0 is the amount of iodine in the sample at time D is equal to 0. Which the following function is K, mods the amount of iodine remaining after T hours, where A0 is the amount of iodine in the sample at T is 0. There are 24 hours in a day, so T is 24D. Okay, so here is the same type of conversion, right? Or very similar. Do we just plug in 24D over here, or like D over 24? That's the confusing part, right? So we can always just check. We want, let's take a simple example. D is days, and we want T, which is in hours, okay? So when it's 1 day, so H of 1, we want that equal to K of 24. Okay, because in 1 day, D is equal to 1, D is in days. There should be T is 24, or 24 hours. T is in hours, right? And it tells us 24 hours in a day. Okay, so these two should be equivalent. So we can plug in to these and check that it's the same. So what's H of 1? It'll be A0 times 0.5 to the 1 over 8, right? H of 1, I'll even write. Okay, so we plug in T as 24 into these. Which one would we get? Which one matches this guy? When T is 24 here, we get A0 times 0.5, which is not this, right? Over here, we would get, when T is 24, we get 0.5 to the 8th power, which is not this again. When T is 24, we get 24 times 3 as the exponent, which is not an 8th. Over here, we get 24 over 129 as the exponent, which is an 8. So the answer is D here. Okay. That's how I would approach these problems. All right, to just carefully check that they're equivalent. Just plugging in a simple equality. Okay. What are all values of x for which log of x cubed minus log of x is equal to 4? Okay, so we want to solve for x, and we'll probably want to use properties of logs. We can pull the exponent out in front of the log, so it'll be 3 ln x minus ln x is equal to 4. Okay, then this can reduce to 2 ln x is 4. And then we divide by 2 on both sides. Ln x is equal to 2. So x is equal to e squared when we exponentiate both sides. Answer is C. Let f of x equal 1 plus 3 secant x, and g of x is negative 5. And the xy plane, what are the x-coordinates of the points of intersections of f and g for x is between 0 and 2 pi? Okay, so points of intersection, we just set them equal to each other. So 1 plus 3 secant x is negative 5. So we solve for x, or secant x. So we get 3 secant x is negative 6. So secant of x is negative 2. If you're not comfortable with secants, we can just write it in terms of cosine. Secant is 1 over cosine, so let me even write it like this. And then we just invert both sides. So cosine x is negative half. So where is cosine x negative half? If you remember the unit circle, it'll be somewhere over here and somewhere over here, right? So what are those two angles? It should be like 2 pi over 3. 3 pi over 3 is here, so 4 pi over 3 is over here. 15c. Figure shows the graph of a sinusoidal function g, what are the values of the period and the amplitude. All right, so it looks like the average is 0. So we're in good shape. We can directly look at what the max or the min is. It looks like with respect to 0, the amplitude is 3 then, okay? Okay, so you can't be confused with what the definition of amplitude is. There's different definitions in the real world, okay? And depends on what industry you're at. For example, there's peak-to-peak amplitude, and there's like just amplitude, which is with respect to the mean value of the sinusoid. So in this case, once again, the mean value is 0, the average value. So we just look how much it goes up or how much it goes down from 0. And that's 3. So the amplitude is 3. So we can eliminate C and D. What about the period? The period is when it starts repeating itself again. So if we just take the peak, for example, over here, it's at 3. And then it happens again at 11. So the period is 11 minus 3, which is equal to 8. Which the following is the graph of the polar function r is f theta, where f theta is 3 cosine theta plus 2 in the polar coordinate system for theta is between 0 and 2 pi. Okay, so if you don't remember how this looks at all, we can just start plugging in values of theta. For example, when theta is 0, then what's r equal to? R would be, or f of 0 would be 3 times cosine of 0 plus 2. So let me even with that. Cosine 0 plus 2, which is 3 plus 2, which is 5. So when theta is 0, r should be 5. Over here, r is only 4. Same thing for over here. So we can eliminate these two. Okay, so there's 2 more choices on the back, but we eliminated 2 of them already. So f theta is 3 cosine theta plus 2. Okay, so r is 5 here, and r is 5 here, all right? So now we can plug in another theta. Maybe like theta is pi would be useful. So what's f of pi? That would be 3 cosine of pi plus 2, which is negative 3 plus 2, which is negative 1. Okay, so in the pi direction, which is over here, right, r should be negative 1. So when theta is pi, r should be negative 1. So it should be over here. But this one, it looks like it's 0. So probably not that. So the answer is D, but let's confirm. When theta is pi, so it's pointing this way, our r is negative 1. So it goes back in the other direction over here. So this matches, right? Answer is D. Let me see how many more. Okay, so these 2 are the last no calculator ones. Okay, where all values of theta is between negative pi and pi, for which 2 cosine theta is greater than negative 1, 2 sine theta is greater than root 3. Okay, so let's just solve for theta for each one and see what happens. Okay, so cosine theta we want to be greater than negative half. And over here, sine of theta, we want to be greater than root 3 over 2. Okay, so let's draw 2 different unit circles. Okay, so where is cosine theta greater than negative half? All right, well, we know that cosine theta is negative 1 over here. All right, so at some point here, it would be cosine theta is negative half. Similarly, somewhere over here, cosine theta is negative half. So everywhere else over here that I'm shading in, cosine theta is greater than negative half. All right, so what are these two angles over here in this interval, negative pi to pi? Well, over here, it's 2 pi over 3. And over here, it would be negative 2 pi over 3. All right, hopefully that looks right to you. Now, how about this inequality? Sine theta is greater than root 3 over 2. Well, where is sine theta equal to root 3 over 2? Similar like how we found here was, where is cosine theta equal to negative half? Was that these two angles? So where is sine theta equal to root 3 over 2? It's somewhere over here. All right, and then somewhere over here. Okay, you can even think sine of 0, when theta is 0 is 0. So I keep increasing. Over here, sine of pi over 2 is 1. And then over here, sine of pi is 0 again. So somewhere here and somewhere here, sine theta would be root 3 over 2. What are these two angles? Over here, it would be, what's the angle over here? It should be pi over, should be like pi over 6, right? And then over here, it should be 5 pi over 6. Sorry, not pi over 6, pi over 3. And over here would be 2 pi over 3 also. Okay? So this inequality will be held in this region, right? So we just want the intersection of these two, which is just over here. So it's between pi over 3 and 2 pi over 3. So the answer is D. Okay, that's how we solved that one. Or that's how I would solve that one. Now, last one in the no calculator portion. Polar function given by r is f of theta, which is negative 1 plus sine theta. As theta increases on the interval, theta is 0. Theta is greater than 0, but less than pi over 2, which the following is true about the points on the graph of r is f of theta in the xy plane. So it asks us if it's below or above the x-axis, and is it getting closer or farther from the origin. Okay. So r is negative 1 plus sine theta, or, yeah, let me write it like that. How does the sine look like between 0 and pi over 2? So I'm going to graph it now. It looks like this, right? It'll reach the maximum value of 1 at pi over 2. So as theta increases from 0 to pi over 2, this term would be increasing. So our r would be getting less negative. All right? So when r is getting less negative, and it's approaching when r is pi over 2, even though we're not including that, when r is pi over 2, r would equal to 0. Okay? So it would be going from, r is going from negative 1 to 0. So it's getting closer to the origin, because when r is 0, it's at the origin, right? So it will be some negative value, and then it gets less negative and approaches 0. So it should be getting closer to the origin, so we can eliminate B and D already. Okay? So now, is it below or above the x-axis? Well, when theta is, let me draw another set of axes. When theta is some positive value, like over here, when this is like theta, r would be negative. So it would be pointing over here, actually. So it's below the x-axis. So the answer is C. Okay, and we're right on time for about 20 minutes. So please like this video if you found it helpful, and please also subscribe if you haven't already. And I'll be finishing up the last few problems, the ones that require a calculator, on the next video. So I'll see you in that video. Bye.